The observable universe contains roughly 10 to the power of 53 kilograms of matter. If we treat that mass as a black hole and calculate its Schwarzschild radius, we get approximately 46 billion light-years, which, astonishingly, is almost exactly the size of the universe we can observe. Coincidence? Maybe. Or maybe it's a clue that the universe itself behaves like a black hole. Or perhaps it is one. In our universe, there's a boundary we can never cross: the cosmic horizon. Beyond it, light has not had enough time to reach us since the Big Bang. It's the edge of what's visible. But here's what's strange. This horizon behaves mathematically almost the same way as an event horizon, the invisible boundary of a black hole. Both represent a limit where information cannot escape. Both define a region from which no signal, no photon, no data can ever return. Inside, time flows differently. Outside, everything seems frozen. Could that similarity be more than coincidence? Einstein's equations tell us that mass curves space, and space tells mass how to move. The more mass you have, the more space-time bends. At extreme scales, that curvature becomes so intense that space itself folds in on itself, creating a black hole. Now imagine, what if our universe was formed inside one of those folds? A newborn cosmos, expanding within the event horizon of a parent black hole. To an outside observer, the collapse would look final, but from the inside, a new universe could be unfolding, just like ours. When a massive star dies, its core collapses. Atoms are crushed beyond recognition. Protons and electrons merge into neutrons. And if the collapse continues, space-time itself gives way. To an observer outside, everything falling in seems to slow. Time stretches until motion stops. But from the inside, time continues normally. Matter doesn't freeze. It moves forward, following the curvature of space. Theoretically, this new region could expand, forming stars, galaxies, even consciousness. Sound familiar? That's the Big Bang, from another perspective. The math is hauntingly consistent. If our universe were a black hole, the density required to match its size would be about 9.9 times 10 to the negative 30 grams per cubic centimeter, almost identical to the actual average density of the observable cosmos. Even the rate of expansion, measured by the Hubble constant, matches what's expected for matter trapped within a space-time horizon. It's as if the equations describing a black hole and the equations describing our universe are two sides of the same coin. But there's something even stranger. Recent research, led by astrophysicist Lior Shamir, suggests our universe might actually be rotating. By analyzing the spin direction of over 200,000 spiral galaxies, he found that nearly 65% rotate opposite to the Milky Way. A cosmic imbalance. In a random, isotropic universe, that shouldn't happen. But if our universe were born from a rotating black hole, a Kerr black hole, that rotation would be inherited by everything within it. Every star, every galaxy, every atom spinning in the same ancient dance. A Kerr black hole is not just a pit of darkness. It's a whirling vortex of space-time itself. Mathematically, inside it exists a region called a white hole, a mirror image where matter doesn't collapse inward, but instead erupts outward. Sound familiar? It's what we see in the Big Bang. Maybe our universe isn't just inside a black hole. Maybe it is the white hole region of a parent black hole, the other side of a cosmic mirror, Every black hole in our universe could be doing the same. Each one, a seed. Each seed, a new universe. Picture a vast, infinite tree. Each branch, a universe. Each leaf, a galaxy. Each root, a black hole connecting one cosmos to another. When a black hole forms in our universe, its singularity might ignite a new cosmos on the other side. That new universe would have its own laws of physics, its own constants, its own history. In this view, the multiverse isn't a sea of bubbles floating in a void. It's a living structure, where every death is a birth and every collapse, a creation. If our universe was born from a black hole, then the cosmic microwave background, those faint ripples in temperature, might be the fossil record of its parent's final collapse. But here's the problem. If black holes create universes, where does the first one come from? Does the chain go back forever? Or was there a first universe, the one that started it all? And if our universe is inside a black hole, what happens when our black holes create new ones? Are we the ancestors of future universes? Would they ever know we existed? The theory fits the math, but challenges everything we think we know about beginnings. Because if the Big Bang wasn't the start, then maybe there was never a true beginning at all. What do you think? Is the universe a cycle, or did something or someone light the first spark?
Imagine this. You, alone on the moon. There's no sound, no wind. The horizon stretches endlessly in all directions, a barren wasteland beneath your feet. And above you, a black sky scattered with stars that don't twinkle. No air, no atmosphere to distort their light. And in the middle of this void,